Hello, my name is Carl Allen, the author of The Polls Weren't Wrong. The field of inferential statistics and political polling is the only science that I'm aware of in which the consensus of experts in the field are objectively wrong about some basic mathematical and scientific facts. My goal is to fix that. I believe I did so in the book, and the process is underway. But the process doesn't always just start at the top, right? My job as an educator is to give people the tools that they need to understand this, not wait for academics to come together and agree on it, but you all, maybe you're a teacher, maybe you're an educator, maybe you're a student, maybe you just are kind of interested in how political polls work, how science works. What I want to do, I'm going to make a few videos. What I want to do is summarize my book in a way that is probably not very entertaining, but it's at least educational, and it explains the underpinnings of how polls work. When I say something is introductory, in most people's mind, they think that means it is simple. And it's kind of simple in that it is easily taught and understood, but because of the topic that we're dealing with here, it is not well understood even by experts in the field. The first question for any discussion on political polling, and I'll be very quick about this part, why do polls in the first place? Why do political polls? Do we really need them? That's kind of a matter of opinion, but as someone, maybe I'm biased, but maybe as speaking as someone who wasn't, why would we do political polls? We do political polls to know something about a population that is too large to possibly speak to every individual of that population. So when we ask registered voters, if the election were today, who would you vote for? If we can take a random sample from that population, and now don't get ahead of me and think about how hard a random sample is, and is the sample representative, and how do we weight? No, don't get ahead of me. If we are able to take a random sample from a population of registered voters, then we have a very good idea, not perfect, but a very good idea of what that population believes. If they believe that abortion should be legal, gay marriage should be legal. This is a very common issue-based polls, right? More commonly, we talk about who would you vote for if the election were today. Now, in my book, I beg readers not to skip ahead, because the fundamentals of the math that underlie political polling are so poorly understood that they are misrepresented, and ultimately they punish pollsters who do good work. And I want to fix that. Polls are the only scientific tool that we have for measuring population preferences. It is a scientific tool, but by the nature of the mathematics that underlie political polls, they are an imprecise, inexact. You can debate whether that's useful or not, but that is what they are. That is why we do them. When we start talking about the math, some people kind of enjoy the math, some people, they don't want to talk about it at all. The formula for the margin of error, and I'll post it up on this side here, the formula for the margin of error is not that complex as far as mathematical formulas go, right? You probably know some more simple mathematical formulas like a squared plus b squared equals c squared, right? Well, that's a good example that I like to use because if you remember back in math days, geometry, you can only use that formula for right triangles. If you plug an A and a B side for a triangle that is not a right triangle, and you try to use that formula, your output, the c squared, will be wrong. It will not be accurate. So, as a scientist, as someone who enjoys and I think maybe understands data, plugging numbers into a formula does not demonstrate or even remotely imply comprehension. If I give you a squared plus b squared equals c squared, and I give you a right triangle, presumably most learners could plug the numbers in and get the right answer, right? But that's not comprehension. Comprehension is understanding when you can apply this formula, and then, bigger picture, modifying shapes and modifying equations to your benefit. So how does the margin of error, this side, how does the margin of error formula work? What is the margin of error? The margin of error, just like the Pythagorean theorem, you have an input and you get an output. The output with the margin of error formula is plus or minus a percentage, which is a range of likely values. What does that margin of error apply to? This is a very simple, I hate using the word simple, but I'll use it here. This is a very simple question with a surprisingly complex answer. I believe I introduced it in chapter 2 of my book very, very early. Experts in the field, as it pertains to political polls, do not get the answer to this question correct. Okay? The margin of error formula, as it pertains to political polls or any poll. So remember, political polls are just a subset of any number of different applications of this mathematical tool that we can use. Take a random sample from a population, get an output with a margin of error. What does that margin of error apply to? When we talk about political polls, we immediately go to the abstract concept of an infinite or extremely large, uncountable population. But as a scientist, as an educator, I say, okay, uncountable things, infinities, near infinities, very large numbers, are very hard to comprehend. So, could we possibly simplify this for learners, for educators, for anyone who wants to understand what the margin of error means? Because this is very important. When we do political polls, we are dealing with an abstract because the population size is too large to possibly contact everyone, even though that's the population, the group of people we want to know something about. But we can use smaller population sizes. You can use populations of any size, and the formula works just the same. So why does that matter? It's the same reason when you're talking about billions in science or math. Professors like to simplify it into hundreds or thousands, numbers that our brains can feasibly comprehend. The margin of error formula is not an abstract concept. It is not hypothetical. It is testable, it is observable, it is provable. You can test it, and it is true.